This is the screencast for section 3.5, example 5, a trigonometric second derivative. All right, so the first derivatives of the basic 6 trig functions you should have memorized, and then you might come into some of the other derivative rules when taking a second derivative. So for example here, we're trying to find y double prime if y equals the secant of x. All right, well y prime, so the derivative of secant x is secant x tangent x. So the second derivative is going to use the product rule because it's secant of x times tangent of x is what we're taking the derivative of. So I'm going to take the derivative of secant by itself, so that's going to be secant x tangent x, and then leave tangent from the original alone. Then I'm going to add the opposite, so not the opposite, but the vice versa. Secant of x gets left alone, and then derivative of tangent of x is secant squared x. And yeah, you can simplify that a little bit and get secant x tangent squared of x plus secant cubed of x. You could even factor out a secant if you wanted to. Now try problem number 36 is asking us to find the second derivative of theta times tangent of theta. Well, the first derivative already involves product rule. So y prime is going to equal, I'll take the derivative of theta or our x, and that's 1. And then, which I'm not going to write, and then the derivative, and then leave tangent alone. Plus, now leave theta alone and take the derivative of tangent, which is secant squared of theta. Oh goodness, this is going to be messy. All right, now y double prime, the derivative of tangent is secant squared of theta, no problem. But now we have a situation where we have 3 functions being multiplied next by each other. Theta, secant, and another secant. So in other words, it might benefit me to write the first derivative out as tangent of theta plus theta times secant of theta times secant of theta. So now I can follow that pattern that we found in one of our earlier word problems in this chapter, where if you're taking the derivative of 3 different functions multiplied, you follow that same pattern, take the derivative of the first one, leave the next 2 alone, then take the derivative of the middle, leave the other 2 alone, and then the derivative of the last. So first I'm going to take the derivative of theta, which is 1, so I have secant theta plus, or secant theta, secant theta. Now I'm going to leave theta and take the derivative of the middle secant, which is secant theta tangent theta, and then times that last secant, which we left alone. Plus, yet a third piece to this product rule, or version of the product rule, leave theta alone, leave the first secant alone, and now take the derivative of the second secant, which is secant theta tangent theta. Now it will definitely benefit us to simplify some of this. I get 2 secant squared theta plus 2 theta secant squared theta tangent theta.